I welcome you all to Part B simulation experiments of Analog Circuits Lab 18 ECL 48 using Multisim. Today we are going to learn about Monostable Multivibrator. Monostable Multivibrator, also called a one-shot, is a sequential logic electronic circuit that generates an output pulse when triggered. A pulse of predefined duration is produced. The circuit then returns to its stable state and produces no more output until triggered again. Experiment number 4B. Aim: to simulate monostable multivibrator using 555 timer IC. Components required: IC 555, resistor 4.7 kilo ohms, capacitor 0.001 microfarad, 0.01 microfarad, 0.1 microfarad, diode 1N4001G, VCC 5 volts, function generator and CRO. Circuit diagram of monostable multivibrator. Multivibrator IC 555 is a 8-pin IC and VCC and ground. VCC, ground, reset pin, discharge pin, threshold pin, trigger pin, continuous voltage, control voltage, control voltage, ground and output pins. It's a 8-pin IC at first. So control to ground, a capacitor of value 0.01 microfarad is connected across control to ground, and then VCC and reset to VCC, it's connected to VCC 5 volts, and discharge pin and threshold pins are connected across a resistor and capacitor. Discharge pin and threshold pins are shorted and connected to between resistor and capacitor, and capacitor is connected to ground 0.01 microfarad value, and 4.7k resistor is connected across 5 volts VCC. And trigger pin. So for trigger pin, a diode and 4.7k resistors are connected across trigger pin to VCC, and capacitor of value 0.001 microfarad is connected to signal generator. This is the input we are using as function generator, or we can call it a signal generator. So, and output is connected to CRO, and the second channel, I have taken the second channel and connect it across the trigger pin, such that I can see at the output where the triggering pulses occurs. That time the output will vary. So here we have used function generator. So write down the specifications of function generator. So function generator, here the input of function generator is a pulse. Frequency is of 1 kilohertz, or you can set it for 500 hertz. So frequency is of 500 hertz, duty cycle 99%, amplitude 1 volt peak to peak. You have to set such that duty cycle is 99%, frequency you make it as 500 hertz, and you should select pulse, ideal waveform. So in the graph, you can see whenever the trigger occurs, the output generates the signal. After some value, it again go back to its normal state. So which means zero state. Again, when using this trigger, input is triggered, output will come, and again it will go to same state. Let's go for the simulation. Right click on place, component, master database, all groups, all families, 555, virtual. Resistor. We require 4.7K resistor in two numbers. I'll take it in two numbers. And capacitor of three numbers. Diode 1N4001G. I'll keep it here. And I require one VCC and ground. So let's do the connections. First, I will rotate okay. I will connect one capacitor across control to ground. Okay, I have connected across control to ground, and then reset pin is given to VCC. VCC pin is given to VCC. After that, a resistor is given to VCC, and then discharge and threshold pins have been shorted, and I will connect one pin. This is connected to ground and make this ground point, and then remaining is triggering. So to give the input, so rotate it 90° clockwise, and diode you should make it counterclockwise or anti-clockwise. Okay, anti-clockwise, and one capacitor. So first here and connect it to here, So diode is connected to VCC and resistor also connected to VCC. And then I need one signal generator. So I will take one function generator. Make it function generator. Positive I will connect to capacitor and negative I will make it ground. And for output I will take one oscilloscope. I will connect it for output, and channel 2 is connected to trigger. So I will connect it to trigger pin, and negative to ground. So now I have to make values. So this capacitor value is of 0.001 microfarad, resistor of value 4.7 k, and this resistor also 4.7 k, and capacitor 0.1 microfarad, another capacitor 0.01 microfarad. So now I have to set my function generator such that I have to select pulse, and then I will give 500 hertz 500 hertz, and duty cycle is of 99%. I can't set it for 100, so I will set it for 99%, and 1 volt peak to peak. Okay, so I will keep it here. So 500 hertz, 99% duty cycle, 1 volt peak to peak, and pulse. So after the connections I will go for run. So click on run, double click on CRO, you will get the waveform. So vary the time base, which means exposition, and stop the signal first, and then make it AC, both at AC. So 2 volts, I make it AC so that we can see output. So vary the time basis such that we can see clearly the output. Okay, now you can see during the rising edge, when the trigger occurs, the output starts positive, or it changes its states until the capacitor discharges, and then it will remain in the same constant state up to next trigger occurs. So this is what the output. I will connect one more channel. So I will take 4 channel CRO, and I will connect first channel, A channel for output, B channel for trigger, and C channel across the capacitor. So C channel across capacitor. So now we can see the capacitor charging and discharging. Set it, make it pause. Select all the channels to AC. AC. So just to show how it works. Okay. See. Now you can see when there is a trigger. See this yellow mark. When the trigger occurs, until this capacitor, you can see here. So this capacitor discharges, the output will be on state. After that, until the next trigger pulse occurs, the output will be on off state. And again, one more time, same thing. When trigger occurs, it will on. After some value, it will goes to zero state. It keep on continuous, depends on your frequency of trigger you give. So this completes your experiment monostable multivibrator. Thank you.